Hello viewers, hello everyone. Welcome to the Fundamental Physics Issue classes. In this video, we'll try to understand what is electric potential and potential difference. Even though they will have the same formula and they have different meanings. Okay, that we're going to understand in coming slides. See, electric potential. What is the meaning of electric potential? Potential means try to understand. Let us take a water in two tanks. Okay, let us take the two tanks are there. Let us imagine the two tanks are connected. One tank you completely filled with the water and another tank is empty. So what will happen if this is opened? Imagine now it is opened. What happened? This high potential, that means water in the high level. The high level to low level, water will go, right children? It will flow from higher level of water to lower level of water. This is what happened. In case of, suppose, let us take the temperature. Two boxes we kept, one we heated at a 10 degree. Okay, 10 degrees centigrade, one is at only 5 degrees centigrade. So that time what happened? Heat will just transfer from 10 degree to 5 degree. Like that only, potential also, when any body having a higher charge to lower charge, it will going to transfer. Okay, when charges also same like a water and like a temperature, it will also, when we will connect or when we attach them, it will potential also, it will passes from higher potential to lower potential. Like suppose you have cell, okay, for your dry cell you are using the metal cap indicates positive and other bump side it is negative. In the electric cell or a dry cell, what you take, when you are going to connect these two terminals in given any circuit, that time also how the charges will move, the electrons will move from negative terminal to positive terminal, and conventional current, what we take, it will move from positive to negative terminal. That means higher potential to lower potential, the charges are moving, right? This is what we call potential. Okay, potential means the charges changes. Why did they change? Because there is a more number of charge or less number of the charge. Let us see how they will move and what is the potential meaning of it. Just a second. Yeah, electric potential means it is the amount of work done in bringing a unit positive charge from infinity to a given point. Let us take one point, unit positive charge. Unit means nothing but one. That's it. Okay, 2 charge, 4 charge, like that. Unit charge means only one positive charge. Unit positive charge. Bringing from where? We are bringing this unit positive charge from infinite distance to some point. This point, where this point in electric field. Okay, children, this is what we call it as a potential difference. I hope this is clear. Potential difference means what is the work done. We need to do some work now to bring in from here to here. That work done, bringing this positive unit positive charge. Okay, represent you bringing unit positive charge from infinite distance. Okay, to a point in an electric field. This is nothing but electric field definition. And see, work done, how much we work done, it does not depend upon the direction. Whichever direction you go, same work done will happen. That is why it is a scalar quantity. So work done, see, work done is nothing but what, children? It is work done is nothing but what? It is nothing but energy what we update. So energy what you have, in which direction also energy same only. So energy does not depend on the factor direction. So it is a scalar quantity. So for electric potential, see, electric potential, we can take it as a V is given by amount of work done bringing a unit positive charge. So W by Q we write. Okay, W is work done bringing a unit positive charge is Q. So you know work done, we can write energy. SI unit of energy is what, children? SI unit of energy is joules. Okay, similarly the SI unit of work done is nothing but energy only. So that's why. And the charge, SI unit of a charge is coulomb. We know this. So that is why we can write the SI unit of this electric potential V is given by coulomb. So work done is joules per coulomb. Joule per coulomb is one more term we can call it as a volt, because the scientist Volt is invented this. Okay, electric potential, so we can call his name as a volt, or we can see no voltaic cells and all. So he only invented all this. So that is what we can volt. Okay, difference between two units we get for using the voltage, or how much bulb will going to consume. Suppose you can one bulb across this bulb, how much voltage is coming. So that and all depends upon this volt. So in day-to-day life, we are going to use this formula very much to calculate the the potential difference between any two terminals and all. Okay, children, I hope this is clear. What is electric potential, what is the formula, and what is its SI unit. Yeah, now see what is the potential difference. Before what we learned, it is the electric potential. Electric potential means from the bringing unit positive charge from infinity to the point in an electric field. Now, electric potential difference is difference between the two ends. From infinity to that point is nothing but electric potential. From one point to another point is nothing but potential difference. That means work done. We need to do some work to bring this unit positive charge. Okay, unit positive charge from where to where? From one point to the another point. So that is nothing but the potential difference. Okay, so why they will move? Suppose you connect one battery. So why the charges are moving from here to here? Because there is a potential difference. So outside it will move like this, but inside the cell they will move from positive to negative. Okay, so this is what the potential difference. Potential difference, the amount of work done. So you need to bringing a unit positive charge from one point to the another point in an electric field. Okay, again this is a scalar quantity. Okay, its SI unit is, formula is given by, potential is given by work done by charge. So work done is coulomb and the charge is, work done is joule and the charge is coulomb. So joule per coulomb, we can write joule per coulomb, or we can write it as a volt. Okay, this is the SI unit of potential difference and electric potential, both it is same. It is responsible for the flow of current in a conductor. Okay, the electric potential is responsible flow of electrons in our electric current in a conductor. Because there is a potential difference, that time only you can see the flow. Suppose imagine the water is there in a container. It is at there is no any slope. Water does not move. It will be stay like this. Suppose in a pipe. Now you just make inclination. Okay, you make inclination or one more pipe you connect with, there is no any water. That time this water will flow like this, because here no water, here more water is there. It is completely filled. You made small hole outside in the second box, no water means it will come from there to there. That means there is a difference in the water level. Here water level is more and here water level is less. That time only water can move here to here. Because why the water will move? That means why the current will flow? Because of there is a potential difference. Current will flow because of potential difference. VA minus B we can get. But here water will flow because of there is a level of water is changed from here to here. Okay, that is what we can understand here. And measured by a device called voltmeter. We measure the potential difference between the bulb or between any 2 points in the circuit by voltmeter. By connecting it parallelly, we're going to connect this parallelly with that resistance what we taken, and we're going to measure the potential difference. So it have very high resistance, so we're going to connect like this. Okay, we understood what is voltmeter and its working in the next videos. Yeah, I hope this is clear, children. Yes, children. So after electric potential and electric current, now try to understand what is the electric circuit and its component. Okay, we'll try to understand now what is electric circuit and its components. Okay. Yeah, let us see what is electric circuit first. You know, circuit means what, children? It is a closed path, right? That is what we can call it as a circuit or a closed loop. We can call circuit means is a closed path which is containing the so many electrical components. Okay, which are that electrical components? Like bulb. You can see in your home that to get the bulb you must have one light. Okay, and to on and off you have on switches. Okay, and other appliances like a switch will be there, and to give the energy, the main thing required is a source, right, children? And to connect this light source and the switch, we require the wires. Okay, we require the wires to connect this. So like this will be the simple electrical circuits look like. Clear, children, how simple electrical circuits look means it will contain one bulb to indicate current is passing or not passing. We require the source primarily. Okay, without source there is no power. So source is very important, like how the sun will be source of light. Like that, here the electric cells are batteries. They are the source of electric currents. Because from this source, if electricity coming out, that will be going to connect to the bulb, and you just don't want to on and off. That time you need to use the switches. Okay, children, you can see here figure the bulb, and this is cell and switch. Here open circuit and closed circuit. We open so that bulb is flowing, and closed circuit and open circuit we can see up. So here, open circuit means no current flows, and a closed circuit, when the circuit is closed, that time the bulb starts glowing. Okay. Okay, what is the electrical components? Instead of writing all the time, this is writing the bulb and making into and the cell. Okay, it is difficult. That is why to go further, they're going to use the symbols instead of this bulb. We're going to use some small symbol. Okay, see, suppose we have one full name. Instead of calling full name, what our parents will do is just call with the small names. No? So like that only here also. If so many electrical appliances are there, instead of writing the switches, bulb, or cell every time, they're going to use the symbols to represent all this. Okay, that is what we call as a circuit symbol. Okay, let us learn that. Yeah, you can see the some of the circuit symbol here. Components actually, I will see here. This right. These are the components and these are the circuit symbols. So component like electric cell. See, electric cell, you know, like this instrument with metal cap contain and the pump. The metal cap is positive and this is negative when you take a cell. But this cell we can write easily using the two lines. One bigger line and the smaller line. The bigger line indicates the positive terminal and the smaller line indicates the negative terminal. This is a symbol of the cell. And the battery as a combination of the cells. Battery is nothing but two or more cells is nothing but a battery. So we're going to connect the cells like this. Okay, one positive to negative, again positive to negative, again positive to negative. This is what we call as a battery. We cannot connect negative and again negative like this. Okay, we can connect like this negative, negative. What happened? They're like, no, they is not possible to flow the current. So we always connect the cells in this fashion. And the plug key, it is like act like a switch. Okay, it is act like a switch only. This is what a plug key. And the plug key is open now because there is no connection between this. When you put the key, plug key is on, that means when you put one dot is showing here. That shows there is a connection between this wire to this wire like that. And the wire joint, if you're going to join any two, what we symbol, use the symbol like this. And the wires are crossing with each other without joining. Suppose one wire is going, one more wire, there is no any link between this and this. That time we are going to just, we can take the symbol like a round. That shows that there is no connection with the, only it is going outward, it is going. And electric bulb, instead of showing the symbol like this, we are going to use the electric bulb like M shape we can write, and you can circle it also sometimes, or without circling we can write the symbol like that. And the resistor or resistance. Okay, resistor or resistance are V's. We are going to join like V's, the resistance. It is somewhat disturbing in the medium, no? So R we can write. And the variable resistance or rheostat, we can change variable because we can tune this. How your radio, and then we're going to tune for FM, no? With the good channels, we're going to tune it. So or vary. So that is what we call variable resistance. And ammeter symbol like this, and voltmeter we can use the symbol like this. Okay, and the galvanometer also use a symbol like this. Clear, children? These are the some of the circuit symbols we're going to use to study in this chapter further. Okay, children? Yeah. Let us see some of the measuring devices to measure the current. We're going to use some device. We're going to measure the. Okay, let us see this. To measure the current, we're going to use ammeter. Okay, to measure the current, we're going to use ammeter. Okay, ammeter. Okay, to measure the voltage, we're going to use voltmeter. Okay, voltmeter. Voltmeter we're going to use to measure the current, and to measure the direction or detection of the current or direction of current we want, that time we're going to use a galvanometer. Or all this combinedly are present in one measurement. That is, if you go to higher classes, no, they will going to use that boxes and all. Okay, that are not required for you. Remember, this three is, it will ask the questions: meter, ammeter, voltmeter, and galvanometer. This is also for current, this is also for current, but it will show direction of the current and the detection whether current is there or not. We cannot measure how many are 2 volt, 2 ampere, 3 ampere like that. We'll just tell which direction is current is moving, or present current is existing or not existing, we can tell. Okay, and this ammeter gives them exact readings, and voltmeter gives the exact voltage in the currents. Okay, children, I hope this is clear. Ammeter first. Yeah, this annotations. Yeah. It is based on the connect. You see, it must be ammeter is a device. Ammeter means it is a unit of current, right? Ampere. Okay, children, ampere, it is a unit of current. You know, current is a fundamental unit, one of the fundamental. In that, we measure the current using amperes. And the device which is measuring ampere, no, that is indicates the ampere. And meter. Meter means what? It is just a unit or measurement, what we call as a meter. So it try to remember A for ammeter. Use the measure the current, unit of current. So it must be connected in series in the circuit. We always connect the ammeter in the series. Suppose this is the circuit. Okay, let us take the bulb we taken and we need to take some ammeter here. Okay, here or here, whichever you want, you can take the ammeter and you connect it to the bulb and switch. You can connect the switch or plug in your wish. So this is what the basic or simple circuit. When you connect like this, no, whatever the current flowing in a circuit, in the series, you're going to detect it, because positive side of ammeter must be connected to the nearest positive terminal of the battery of the cell, and negative is connected to negative terminal. So you can see here, it is the bulb. Okay, here ammeter is there. Ammeter positive end is indicated as a red. Okay, this red is for positive and this black is for negative terminal. See, this positive terminal is connected to positive of the cell. Okay, and negative is connected to negative end. It will go, see, it will come like the second, it will go again coming to negative of the cell. So that is what we are going to connect. Positive and negative, it has two terminals. The two terminals we need to connect positive to positive of the cell and negative to negative of the cell. Then only it will work. Clear, children? This is the ammeter. And ammeter having a very low resistance. Okay, because it having very low resistance, and we're going to connect this in series with the circuit, so that because of low resistance, no current won't waste in the ammeter. That's why whatever the current will pass, entire current will pass through this. But again, one more device will come, that is what we call voltmeter, to measure the current, that we'll see. Yeah, next device is a voltmeter. See how voltmeter will work. Yeah, voltmeter must be connected in parallel to the circuit. Since the circuit is there, no, it is connected parallelly to the this one. So in the last what you saw, see, ammeter you can see here, no, ammeter is connected positive terminal to positive and negative terminal to negative, and is connected in the single line. It is not a bifurcated. But you can see voltmeter, no. Voltmeter, it is connected positive to bulb and the cell, all are connected in parallel. Parallel means at the some point all are going, one point other. See, one is we connected here, bulb connected, here we connected a cell, and here we connected a voltmeter. So all are in parallel. At one point it is going. Okay, like this it is going. But in case of series, how we see, the bulb is there, and the cell is there, and our ammeter. Somewhere in between, ammeter is there. All are in a single line. That is what we call series. Series means they connected in a single line. Ammeter, this voltmeter means we need to connect a parallel to the circuit, not in a single line. The starting positive and negative terminals are same for everything. See, this is positive terminal, here also positive, here also positive. So all these three terminals merge to a reduced terminal, nothing but one only. Like this we can write. So voltmeter having a high resistance. It is very high resistance it will have. That is why we cannot connect this to series. When we connect this to series, whatever current will come, your voltmeter only absorbs so much current and your bulb does not glow up. So that is why we need to connect this to parallelly. So that what happens, whatever high current is coming, your share will go here and it will also go through this one. Because high resistance current won't go to this path. The current will follow this path only. Clear, children, regarding voltmeter and ammeter? Voltmeter used to measure voltage, and ammeter used to measure the current in the circuit. Voltmeter you never forget, because voltmeter for voltage, and the only current you forget, it is for ammeter used to measure the current.